Second section, Unit 10, Reflections. Reflection is a transformation that moves a figure, the pre-image, by flipping it across a line. Here we have an example of the pre-image triangle ABC that got reflected over the red dotted line, and here's the new image after it got reflected. Remember that we can tell it's been reflected by the A prime. This is the original on the left, and on the right is the new one after the reflection. Just a review from Algebra 1 on how to write and graph equations. Horizontal lines. Anytime that you see an equation and y equals 2, this means it will only cross the y-axis. So it's going to be a horizontal line that crosses at 2. Y equals -4, it's a horizontal line. Slope is 0, so it's flat, so it's going to cross the y-axis at 4. It's important that we remember how to graph these because we'll be reflecting images across these lines. Vertical lines. Vertical lines are written with x equals. So anytime you see an equation, it just has the x. Means the slope's undefined, and so x equals 2 is going to be a vertical line that crosses the x-axis at 2. X equals -4, that's going to be a vertical line that crosses the x-axis at -4. So x equals -4 is the vertical crosses at -4. Here's an example where we're going to take quadrilateral ABCD, and we have to reflect it across a vertical line x equals a. So we're going to draw the line of reflection. This happens to be x equals 2, and so we're going to reflect this quadrilateral across x equals 2. Pick a point, count over, always vertical or horizontal to the line. So in this case, if I pick point B, it is going to be 1, 2, 3, 4, 5. So the distance from B to the line of reflection is 5. And so we're going to go over to the right 5, and that would be B. And we'll repeat the process for each vertices that we have. Step 3, go the same distance on the other side of the line. We're reflecting over on the other side. Label the new points, and you continue with the other 4 points. And so that you can see that when we reflect, A preserves distance from here, so it's going to be, so it kind of gets flipped over the line, y equals a. Reflecting across the y-axis. Here's a triangle, and we got to reflect, and the y-axis is here. And so if you look, A and C are going to go on the right side of the y-axis, and T, since it's already on the right, it's going to get flipped over to the left side. So what do you notice about the x and y coordinates of the pre-image and the image points? So we'll come back. So here's reflecting across y equals x, or the y-axis. 1, 2, 3, so C is going to be on the other side. A, 1, 2, 3, so it's going to be 1, 2, 3 on the other side. So C prime is 3, 7, A prime is 3, 2, and then T, since it's on the right side, we're going to go to the left side. So it's at 2, 2, and then when we reflect it across the y-axis, it'll be at -2. It says, what do you notice about the x and y coordinates of the pre-image and the image? Let's see, -3, 3, 7, 7. looks like the y's are the same, and the only thing that got changed were the x's, which makes sense because before we had to go to the left and up, and then now we have to go to the right and up the same amount. Here's an example where we're going to reflect this quadrilateral, and this time we're going to reflect it across the x-axis. So instead of going horizontal, this time we're going to go vertical. So A looks like we're up 1, so we'll come down here 1. A is at -1, 1. And when we flip it, our new coordinates will be -1, -1. And then it says, what do you notice about the x and y coordinates of the pre-image and the image? So in this case, remember we're going across the x-axis, and so if we look at the x-coordinates, all the x-coordinates are the same, and this time the y-coordinates change. So I went from 1 to a -1, +5 to a -5. So as far as left and right, so if you look at coordinate or the vertex A, went to the left and up. This time we went to the left and down. So we're going the same distance to the left, but instead of going up 1, this time we went down 1. Reflecting across the line y equals x. It says refer to reflection on worksheet number 6. Remember how to graph y equals x. Slope-intercept form, the slope is going to be 1, and the y-intercept will be 0. So the line's going to cross at the origin at 0, and the slope is going to be 1, which means you go up 1 and over 1. And so that is the line that looks, diagonal line that looks like this. And so we have to reflect across this line. Now remember that when you reflect, that you have to go perpendicular in the distance of the line. So if I look at the f coordinate, it's located at -3, 0, and I have to go perpendicular, and if you look, the distance is, if I go diagonally, it looks like it's across a block, another one, and then we go, and it should put me here. H, you have to go perpendicular. It looks like I go through 1, 2, 3, and so I need to go the same distance on the other side. Continue that for all the points. And so here's the reflection of this quadrilateral across the line y equals x, and if you notice the coordinates, -3, 0, 0, -3, and if you notice, the x and the y's got switched. So anytime that you switch any image across the line y equals x, then all you really need to do is take your coordinates and flip. Here's a little cheat sheet, a little summary on how to reflect. Remember, if we reflect across the x-axis, then we take original coordinates, and then the y is going to get changed. That's the opposite of y, -y. So if this was 3, this would be -3. If you reflect across the y-axis, the original coordinates will be, the x will get changed. That's the opposite of x, -x. Whatever x was, it's going to be the opposite. And then if you reflect across the line y equals x, then your coordinates are going to get switched. Take your original coordinates and you flip them. That's the end of the section on reflections. Should be ready for the practice.